Good morning, everyone. Myself, Vinay B. Assistant Professor, Department of Mechanical Engineering, Sahyadri College of Engineering and Management, Mangalore, Karnataka. Today, I am going to introduce you to industrial automation and, more importantly, how you can build a strong foundation in PLC-based systems. This session is not just about theoretical concepts; it is about developing an industrial mindset in the young engineers. So, if you see this slide, I can tell you what we are going to learn in this session, in these sessions. You can think about any system, there will be three aspects to be learned. One is as per the common person, one thing as per the student, one thing as per the engineer. So, if anyone want to learn and if they have to build a career, they should choose the special field. In one such field is PLC and industrial automation. So, the overall objective is to give you the practical approach to industrial application using PLC and automation. What we can learn here, one is real machine understanding, control logic development, ladder logic diagram, timers, interlocking and safety, sequence control, debugging and fault finding, industrial mindset. So this will definitely give you the overview about how industrial automation works, and it definitely gives the insights of industrial thinking. So what is industrial automation? Any process if you want to start, any process if you want to control. So if we make it the human intervention as less as possible, that leads to a term called as automation. The automation is doesn't have exact definition as 1920s automation is different, 1930s automation is different, 50s automation different. At currently, automation is entirely different scale. So there is no definite definition for the automation. So what we are going to learn here, a step-by-step framework to bridge the gap between mechanical theory as well as the real-world industrial applications. So who are going to get benefit from these videos? Mechanical and robotics and automation engineering students. So what we are doing here is we focus 30% conceptual or theoretical things, and based on those knowledge, we are going to build a 70% of the practical approach. So clubbing together the 100% conceptual as well as theoretical knowledge on industrial automation. So we are going to learn through the online media, YouTube. I'm going to set up a videos, share with you. Whenever you have queries, you can contact me. And the primary objective is to build industrial thinking. So what exactly this? In the classroom, we learn what control system means. For example, if you see here, the P is equal to F by A, that is force by area. Pressure is equal to force by area. We are going to differentiate with respect to certain quantities, time. It focuses on isolated formula and generic diagrams. Treats mission as the abstract concepts, such as the return grade. That means we are going to learn, yes, this is going to be inculcated in the practical applications, but students don't know how to inculcate these things. So we are converting these into a practical approach. That is how factory floor works on this. So what are the inputs for this? What are the outputs for this? How we are going to apply this? Basically, this formula contains the individual terms, boundary conditions, everything. How do you approach in the industrial applications? That is how this motor works. It focuses on how you give input, how you control the input, how the timer will work, how the logic gates will work, and finally, how the system works. So, this approach breaks machines down into systematic input, output, system and sequence loops. And what is success in this? That means what is the output of this? It is a running. The system runs, the output is okay. If system doesn't work, so you have to know how to debug it. So that is what the industrial automation teaches here. So what we are going to learn here is you will learn to design, implement and debug control logic the way engineers do in the real world. So what are all the fields this automation comes? So I have tried to limit some of the applications in the initial classes. As soon as we progress, we are going to discuss with more of different case studies, different domains where automation concepts comes, where students can find their fit themselves in the field of industrial automation. So conveyor systems. In the conveyor system, main objective here is to transfer the object. So here it does object detection, motor delays, stop, start, and packaging using a line routing, sequential packing, right? So for this I need inputs, outputs, microcontrollers, timers. So how we can understand? If the status show you green, it is running. It shows green, it is active also sensor. So red color indicates it's stopped. Somewhere there is a error. So this is one of the case study. Next, automated machines like CNC machines, robots, how it works, water and process plants, how the water level sensor will work in pumps, and whether the human intervention is needed or not. Those things we are going to learn here. And packaging and process industries, automatic filling of a beverage bottles, so capping it, discharging it from the line, and labeling it. Everything requires automation. So each and every case, if you can do one step advent or one step innovation, definitely it's going to boost your career. So that is the basic motto. And why automation is important in this category? See, I told you with the case studies in the previous slide. Now, if you understand every case, we need certain common steps. What is that? If you want to automate, before automation, I don't know how to automate it, that is fine. If you learn automation also, you should know certain common things. What are those? That is one thing is understand the machine. Define the purpose in your language. Your particular language means what? You should know in your brain how to automate it. Before that, understand the basic mission. Next, what are all the physical attributes? What are all the theoretical attributes required to understand the machine and run the machine and control the machine? That is, identify input and output devices. That is, what are the sensors we are using, or motor type, assign PLC registers or addresses. Next, on what sequence it should work. You are basically not doing the sequence, but if you know how to make a sequence, definitely it is going to add an advantage. Next, convert it into ladder diagram. Translate the sequence into different steps. Usually we call them in a PLC server system as the runs. That I'm going to discuss in a later space. Then implement, test, run, check the results. If any problems, debug it, rerun, rewrite, then finally get the desired output. So the physically how earlier automation system we are using a small switch, motor works, it runs the conveyor belt, does something. Later we interface with computers. In present day we are going to interface with a digital control. So definitely how PLC works with the different logic systems is going to be helpful for the future industries or present industries also. So how uh, the basic control helps in understanding the assembly line. Assembly line is very simple here. First, we have to understand what is basic control. Later, how we can add that basic control with the different timing mechanisms. That is will become another set of case studies. For same assembly line, Next, you are going to add a sequence. That is going to be another set of curriculum. That is another set of learning category. Next one comes final product. So if you know these three basic and the intermediate steps, this is going to be final study. So one assembly line which gives you lot of options to learn PLCs. So each and every category we can do many more practical studies. So if you see this slide, it gives you translational matrix from physical to digital. So once our course starts, I'm going to discuss this in detail. So here what exactly gives one earlier was switch was there, now it is input, and in the input also there are two types. One is normally open, normally closed. Here one is power. What is that? Normally open. Usually we used to make the contact. Normally closed, you usually may used to break the contact. So please understand this is going to be very interesting as well as safe approach towards learning how PLC works. So this is the anatomy of a simple ladder logic diagram. This I am going to share with you in a further videos. So how PLC ladder logic diagram helps to control the process. Before that, I would like to take you about the relay logic system, and later we come to this one or two videos more. We are going to learn about the theoretical aspects. So timing, delay, sequence, whatever we saw in the previous slide regarding assembly line, everything comes here. Why timing is required, why delay is required, why sequence is required. If one of these fails, what happens? Okay, especially I will give you a very good case study which is going to be worked out in a Mangalore region regarding this, how why sequence is important. So if any of a student is probably if a student gives a better solution, definitely we can work on the societal problems. So this is the another type of case study. Each case study I'm going to learn with practical exposure in the coming videos. Sequencing, again, sequencing comes into picture. So I would like to conclude the first basic theoretical session on the PLC and automation. I request all of you to go through this, and also I prepared some manual. So every class I'm going to share the simple numericals. Please solve in your own time. If any queries are there, can contact me, and contact details will be shared in the link as well as in the description box. Thank you, one and all. Have a great day.